Hello! So in this module we're going to learn about the activity of parsing a sentence and how to do it with the parsing module in Logic 2010. So far we've learned about that they're complex conditionals, that when we symbolize them we can use parentheses to avoid ambiguities, we have specific rules for how parentheses show up in our language and don't, and official and informal notation when we can drop parentheses sometimes. We have the idea of a main operator and a parsing tree. A parsing tree shows how a sentence was built up from its ultimate pieces, atomic sentences, and the main operator of a sentence in any given sentence is the conditional or other logical operator. Right now we only have the conditional that was added to the sentence we're looking at to build it, added to other sentences to build it. So in this video we're going to learn about the parsing module and parsing sentences, the activity of parsing sentences. So if you're given a sentence, if you're given a parsing tree, and at the top, then you know, oh, okay, I've got a sentence, there it is at the top, and here's how it was built up. But if you're just given a sentence, you can reconstruct that tree. So you could start with the top of it and then say, okay, well, how was this built up? Well, we added that arrow on the right to the P on the one hand and the parenthesis P arrow Q parenthesis on the other hand, and so we could break that down into its pieces, the P and the P arrow Q. And we eliminate from this level of the tree now that right arrow isn't showing up anywhere and those external parentheses aren't showing up anywhere because that's what was added in building that top sentence. So now the right branch as we look at it, the branch on the right of that tree is done because it's down to an atomic sentence, a sentence letter that doesn't have any pieces. But the other branch of the tree is not done because it's still got, it's a complex sentence, it's not a sentence letter, it's got pieces. So we can remove its main operator, that arrow in the middle, and we break it down into a P and a Q. And so there we go. We have, by starting with the sentence, we have reconstructed the parsing tree that shows how it was built up out of atomic letters. And so the way this works is we just, at any given point, if we have a complex sentence, we figure out what its main operator is, get rid of that, and write down the pieces, and we keep going until each branch of the tree reaches sentence letters, which don't have any pieces, and then we're done with the tree. So it's breaking a sentence into its parts, we find the main operator, break into its immediate parts, keep going until we get a sentence letters, and that produces the sentences trees. And so we're going to do that in the parsing module. We're actually going to do a couple of things. You're going to be given a series of symbols, a string, and you're going to figure out whether or not it's a sentence, whether or not it's an official or informal notation, and then if it's a sentence, you'll parse it, you'll produce the tree. So there are really three categories here that we're going to be looking at. There are sentences that are in official notation. Those are built according to the grammatical rules and only the grammatical rules. They're the sentences that are in informal notation, and those are where we built a sentence using official notation and then dropped the external parentheses. And then there's everything else which we call not well formed. We're going to look at that in the parsing, how we do that in the parsing module in Logic 2010 in the program in just a second, but I first want to just give you some examples of the not well-formed stuff. We've seen official notation sentences, we've seen informal notation sentences, both simple and complex conditionals, but we want to look at some things that are not well-formed. So neither of these are sentences. That A arrow Z with parentheses, that might look really good, but it's actually not a sentence because A is not a sentence letter. If we put a P or a Q or an R or anything between P and Z there, a capital letter, it'd be fine, but A is not a sentence letter, so that's not a sentence. And then that P parenthesis Q, that's also not a sentence, pretty obviously, not built according to our rules. So those are non-sentences. And the important thing we want to know about non-sentences is that they don't have trees, right? A tree says that thing at the top is a sentence, and here's how it was built according to the rules. But if we have a non-sentence at the top, well, that by definition is something that was not built according to the rules. And so there's no tree for it because a tree shows how something was built according to the rules. So there are just no trees. You can make up some sort of notion of a tree for such a thing, I suppose, but as far as our trees are concerned, non-sentences don't have them because trees show how things were built according to the rules. Let's hop over to the Logic 2010 module and see what it looks like when we do some parsing problems. So here's a problem, and this is the thing we're going to be working on, and we have to decide, is it official, informal, or not well formed, and we have to break it down. And we can do it in either order, doesn't matter which. So we could say it's maybe informal notation, and we could check it, and it turns out that that's incorrect. These are very easy. We could try not well formed and check that, but that's also incorrect. So we could try, okay, let's try official notation. And now it tells us, oh, that's incomplete. And why is it incomplete? Well, because we need to do the tree. So how do we do the tree? Well, you find the main operator and you click on it. The main operator, remember, is the operator that was added to other sentences to build what we're looking at. And the only operator in this sentence is the arrow, so we'll click on it. Let's try clicking on something else first. Oh, well, there we go. We can click on other stuff, and then they turn red, and the program doesn't like that, and it makes annoying noises. But when we click on the arrow, then we get the tree. And if we click on these, well, we can't break those down anymore because they're sentence letters. Now, it still says it's incomplete, but this is an out-of-date error message. If we now check again, then it's correct. This was correct. Our tree is complete. We have completed the problem. Hooray. Let's look at some more. Sure, let's save that. So here we have what looks very similar, and we could start over with the tree, thinking it might have one. We could click on the Q, that won't work. The P, that won't work. We click on the arrow, turns green, breaks it down, P and Q. So the tree is done. So if we click check, we're told it's incomplete. We've done the tree, but we haven't said what it is. So we have to decide, is this not well formed, informal, or official? Well, we know it's well formed. It's not this option because it's got a tree. So it's either official or informal. Well, it's missing parentheses, and that means it's informal. So we'll check it, and that's correct. Let's just do a couple more of these. A arrow B. Well, it's not the A, it's not the B, it's not the arrow. It's not the arrow. What's going on? Well, if there's no tree, it must be not well formed, so we can check it, and that's correct. But why is this not well formed? Because A and B are not parts of our language, right? Our language, the only sentence letters we use are P through Z. So if we had P, something between P and Z there, and something between P and Z there, then this would be fine, but we don't, and so it's not well formed. How about this? S arrow T arrow P. Well, it's none of the letters. Maybe it's that one. No. How about that one? No. It's not well formed because we're missing parentheses. For this to be grammatical, we have two arrows, right? And with each arrow we add, we have to put in a pair of parentheses. So this should have, if it were official notation, it would have two pairs of parentheses. The one that came in with this arrow and the pair that came in with this arrow. If it were informal, then we could have dropped one of those pairs, the external pair, the part where the parentheses that came with the arrow that was added second in building this up. But there would still be either parentheses around the S arrow T or around the T arrow P, but we don't have either of those. So this is actually not well formed. It's just no good. It's not grammatical. And there we go. Let's look at one more. Okay, so we have parenthesis P, parenthesis arrow Q. Okay, well, we want to see if it has a main operator, and then if it does, we would click on that one. So we want to think, well, if this is a sentence, then one of these two arrows was added last in building this thing, and that's the main operator of this thing. Well, this in here, we stuck this in there by putting the P on the one side and then putting the parentheses around it. So this was added inside of those parentheses with this. So it's not the main operator. So that must be the main operator, and in fact it is, right? Q is a sentence, and P arrow P with parentheses is also a sentence. So we built this thing by putting this in between the Q and the P arrow P. This branch is now done because it's a sentence letter. I think this is in informal notation because it's missing the external parentheses. So let's check it. Oh no, it's incomplete. Why is it incomplete? Because we have to break everything down all the way down to sentence letters. So we need to break this down into its two pieces, the P and the P. We'll check it again, and now it's correct. So that's parsing. There you go. It's pretty straightforward. It's practice just to help us really get comfortable reading more complex sentences and seeing what their parts are. So you'll have some parsing problems for your homework. I think you'll find them extremely straightforward. If you're having any trouble with them, it's just a little thing you're not understanding about the module, and so definitely feel free to post online on the discussion board any questions you might have about it, and we'll be able to get any confusion you have about them cleared up quite quickly. Sometimes it happens, and that's fine, but it's very straightforward to figure out. So good luck with those. In our next video, we will see about doing symbolizations and using this idea of a main operator and how that can help us when we're symbolizing complex conditionals. So let's get to that.